So students, today we will learn how to use different devices to measure the water quality parameters. As you know, there are different methods of measuring water quality, of which thermometric method is one of the very common method. You know that you are using it in the chemistry laboratory, or in previous class also my students have them given a demonstration regarding the visual oxygen parameter estimation. But at the same time, we can go for estimation of these parameters by using some devices, and these are called portable devices, and these devices can be used directly into the water, and we can get a reading and note it down, and for analysis we can go for. We have few of the devices in our laboratory that we want to give a demonstration to you. So here you can see one of the device, this portable device by which you can use. You can see the markings that what is called. First one is pH, second one is electrical conductivity, third one is TDS, total dissolved solid, and fourth one is the salinity. So in one device we can go for four parameters. So you can understand what is the portability and advantage we are getting using this device. Here you can see the one of the display window is there, and there are some buttons. This button, start button, calibration button, these buttons are there, and you can see this is a probe. This is called probe. This is inserted into the water, deep into the water, and there are some what is called sensors. These sensors can easily get the desired parameter. Say for if you are using pH button, this will get the pH. As you know, pH means the hydrogen ion concentration. It will get the measure of hydrogen and ion concentration from the water. So you will get the reading here, and you can easily note it down. And there is no need of standardizing this one. It is auto standardized, and you can use directly into the water. Similarly, if you go for TDS, there is a section, mode section. This mode section can be changed, and you can change the mode from pH to TDS. So TDS means total dissolved solids, which are suspended, dissolved in the water, which are maybe many pollutants are there. So this can be measured. This will not give you the what pollutant is there, but it will give the what is the level of those pollutants. They are very high amount, low amount. This measure it will give you. Similarly, if you go for electrical conductivity, you know most of the ions give the electrons, and, and that will give the electrical conductivity. So this electrical conductivity, in other way, you can say that it shows the saline salt quantity of the water. So this electrical conductivity can be measured from this probe by changing the button to EC, and you will get the total electrical total ions in the water. Similarly, if you go for salinity button, this is salinity button, and this button will give you the total salinity of the water. As you know, fresh water have almost nil salinity, but if you go to ocean or brackish water, you'll get some salinity level, and ocean definitely will get the large high salinity level. So if this button is used, we can directly get the total salinity of that particular water body. So that is why this multi-parameter portable device is used to measure all these four parameters.
So, previously we have seen the multi-parameter device which can measure the TDS, EC, pH and salinity of water. Now, there may be such devices which measure the individual parameter like the pH meter. So, as we know, pH is an important parameter for all the physiological processes like growth, reproduction, feeding, and all. So, this is a pH meter which have a display box, the switch, that is how it is on, and the probe which have sensors which is deep into water. So now we will see how to measure the pH of a particular solution. We will first power on the button. We can see the display box. So I have taken a water solution. We will dip it. So we can see the reading, which is slightly alkaline. So this is how we can measure the pH of a particular solution by this pH meter. Before we have discussed about the titration method of measuring dissolved oxygen, today we will get introduced to the portable oximeter device by which we can measure the DO easily. So this is the portable oxygen meter. This is the power button, and this is a dual oxygen meter by which we can measure both the oxygen in air and the dissolved oxygen by switching this button to mg per liter and the O2 in the air. Mg per liter is for measuring the DO and the O2 in the air is for measuring the oxygen in air. Now this is the probe which we dip in the water. This is the connection of the probe to the monitor, and we get the reading here and the factor temperature here. So this is the probe which can be opened. This portion we dip into the water, and this wire is connected to the main monitor here. Now I will demonstrate you to how to measure the DO by the dual oxygen meter. For this I have taken drinking water in a beaker, and now I will put the probe into it. Before, we have to power the machine, and as we are measuring the DO, we have to switch the mg per liter mode here. So now I will dip it into the water, and you can get the reading here. As we have seen that we are getting the result here, and this is the factor temperature below, and the reading we can calibrate by this calibration button.